Ncert 9.6 from Ray Optics. A prism is made of glass of unknown refractive index. Okay. A parallel beam of light is incident on a face of the prism. The angle of minimum deviation is measured to be 40 degrees. What is the refractive index of the material of the prism? This is a one question. Okay. What is the refractive index of the material of the prism when you have a minimum deviation 40 degrees? Okay. Then that time you don't know the refractive index of the prism materials. Next, if the angle of refraction is 60 degrees, if the prism is placed in a water, till now it is in a air and direct glass medium. It is placed in a water medium. Now predict the new angle of minimum deviation of parallel beam of light. Okay, here we have two questions. One is, first we need to find the refractive index of the material when the light is passing one air to prism, that is when a prism in air, that time minimum deviation is 40 degrees. We know angle of prism is 60 degrees. Basic refractive index formula of prism: A mu g equal to sine of a plus dm by 2 sine a by 2, that we know. A stands for 60 degrees, dm minimum deviation 40 degrees. 60 by 2, it is gives a 30 degrees, it gives a 100 by 2 50. So sine 50 by sine 30. Here little difficulty, we should know the sine 50 value here, otherwise we should use calculator while we are doing. But in exam we should remember these values, so try to remember the standard values. Or if you are a math student, you can derive also, you can find it also. Sine 50 0.7660 by sine 30. Sine 30 is a 0.5 we know, so 0.5. If you divide that, we have 1.532 is the answer. This is the refractive index of the prism material. Now, that is if you are keeping in a water. Question number 2 from this question. In water, when you are keeping, from water to glass, there is a refraction is taking place. So A mu g by A mu w I am writing, which is equal to sine 60 angular prism plus dm dash, which we are going to find now. This dm dash, this is dm, this is dm dash. Now this is in a water, I am going to find the minimum deviation by 2, sine 60 by 2. Obviously sine 60 by 2 sine 30 will take. Now A mu g, that already we found in the above, 1.532, and A mu w, it is given in the question 1.33. I have equated to this refractive index of the prism formula. Sine 30 I am sending this side, so it is 1 by 2. 1 by 2 into 1.532 by 1.33. We have to do simplification. When you are doing simplification, we have a value that is 0.5759, which this sign I am sending this side. Okay, when this sign is sending this side, then it becomes sine inverse of 0.5759. Then what about this? This sign is not there. 60 by 2 is 30, dm dash by 2 separated. Now sine inverse 0.5759, this equal to 35 degrees and 10 minutes. So I have equated 35 degrees 10 minutes, which is equal to 30 plus dm by 2. Further what I did, this 30 I sent that side, then 35 degrees 10 minutes minus 30 degrees, it become 5 degrees 10 minutes. Okay, so again this 2 I will send that side, it will be multiplied. 5 into 2 is 10 degrees, 10 into 2 20 minutes. So the total angle of deviation when it is immersed in a water, dm dash equal to 10 degrees to 20 minutes. Okay, this is the most important numerical in a case of prism. Thank you.